number 10. Great to see our seasonal stack sources alongside with the freshly instantiated variables. If this is your first Git pull to our meetup, I'm Pavel from Epicmax, a pack of Vue.js fanatics who dream in a single file components. We are also masterminds behind Vuestic UI Forever, on a mission to refactor the Vue universe and empower your inner coder. So we launched Vue.js Talks with a mission simpler than console log hi. Swap nerdy know-how, link up with other code crusaders, and spin up the arena where collaboration and creativity loop infinitely. It's been a wild ride watching our little side project compiled into something awesome over the past meetups, and we're hyped to keep optimizing it alongside with you. So, what we have in today's agenda: Rockstar's roster of speakers ready to unload some serious Vue wizardry. The first speaker will be Alvaro Saburido Rodríguez with his shiny, pretty, and post-processed TresJS effects for jaw-dropping visuals. The next one would be Volcan Akyel, Vue Motion, a modern animation library built on top on Motion 1. And last but not least, Andrii Bohdanov with continuation of his previous talk about UnoCSS. It would be API-driven styling with UnoCSS. So let's keep going. Alvaro Saburido Rodríguez. Sorry if I pronounce something wrong. I just think that's the right way, right? So
you're the only person that I meet in a long time that actually pronounce it correctly.
Oh, really? Cool,
Yeah.
Cool. Happy to hear that. So Alvaro is creative software engineer with more than 10 years of experience. He's also author of TresGS, developer experience engineer at Storyblok, and content creator and speaker. So nice to see you there, Alvaro. I'm passing microphone to you.
Thank you very much. Let me quickly try to share my slides. Please let me know if you can see them, and also I'm audible. All good?
Yeah, all good.
Amazing. So, well, first of all, hi everyone. My name is Alvaro. Really happy to be here. Thanks for inviting me. I'm always looking for talk about Vue and cool stuff that we can build with it. So I have this talk that is pretty cool because it showcases a lot of visuals that you can achieve with the library, with TresJS. So it's titled Shiny, Pretty, and Post-Processed. 3.js effects for jaw-dropping visuals. Of course, this was done by ChatGPT. I cannot come up with such cool titles. So my name is Alvaro. I'm a developer experience engineer at Storyblok. My role is basically I'm paid to do open source, which is amazing. I create all the tooling with the team in the Storyblok for the open source, like how you consume a Storyblok with the tooling, CLIs, APIs, SDKs, you name it. I'm from Venezuela, but I live in Barcelona, Spain, nearby. I used to create a lot more content on my YouTube channel. Nowadays, it's a little bit tougher, so I'm looking forward to come back to it. I have a portfolio that I haven't finished yet. Someday I will. And you can always say hi in my socials. Alvaro Sabu is the same in both. Okay, so you can always say hi. I'm more than happy to talk about open source and engineering. So we can start by question what is post processing. So has any one of you actually know what post processing is? Feels good to know that I'm not alone. So post-processing is a technique in video. Well, if you know about post-processing in video, it's mostly the same concept. So basically, it's a technique that you create effects after you render the image, okay? Or you render a frame in a video. So without it, you can create a scene with threads, something like this, where you have a sphere and it has a grid under the hood. But with post-processing, you can create fancy stuff like this, like a glowing or emissive ball that has a glitch effect that like shakes the camera and such. And that's something that you can actually achieve with Vue components and composables. So I'm about to show you that. So as our audience was commenting, and post-processing is just a technique that is used in cinematography and a lot in gaming as well, to add effects on the final render of the scene. So this is one of my favorite like frames or pics from one of a great movie. So it shows like all the depth that you can get with the color grading and also the effect of like the glowing of the doll in the back, and how you can play with the colors, with the exposure, etc. So how does it work? It can look like magic, but it's actually pretty simple. So we have our 3D scene that is compounded by different objects that we have. So we have the camera checking, okay, I have a cube here, I have a sphere, a model of a character here. And every time we want to present it to the user using the canvas, we take a picture of that. Okay, so it's every frame per second. We take a picture and show it in the canvas. So that is what we consider the render pass. On top of that render pass, we start playing with the visuals. So we add a bloom pass that is an effect that will make it shine. Of course, you need to set some properties on the material so it's emissive and you can create light out of it. But you can do other stuff. You can add a pass for a red color. So you can get that glowing objects and then change the color of them. This is additive, so you can add as many layers of effects that you want. The order matters, because if you red color before you bloom, you can get a different effect. But at the end, the final output will be the combination of all those passes into the final output. Let me check also the chat if there is any questions. I guess at the end I can also answer some questions. Okay, so why would you like to do that, right? So there are a couple of reasons why you will like to do it. One is the separation of concerns. So you focus on creating the scene and all the assets inside, animations and such, into the main pass, and then another team probably can work on the After Effects. The second reason is performance, because doing this on the rendering code is going to be way more difficult and way more heavy on performance with the GPU with WebGL than do it with the frame, because at the end we're doing an image and we're photoshopping it to create those effects. Okay, so it's not a live effect that we're applying it to the final snapshot that we're taking. And it gives you artistic control. You can apply more effects than what you will be able to do on the main pass. So getting that concept into TresJS, probably I should introduce TresJS because it's not necessarily as well known as other libraries. It's a Vue custom render that allows you to build a 3D scene or 3D experience using Vue components. Okay, so it translates all the components that you put in your single file components into actually 3D things that are rendered on the canvas. The reason it's called Tres is because it's the Spanish word for 3GS. It's a wrapper of 3GS at the end. And it's pronounced Tres in reference of the 3GS library. Also, the French word was already taken. So I took this because I'm Spanish. So the way you can get started is that you choose your package manager of choice, and then you install TresJS core. And as a pure dependency, you need to install 3GS. You can also play in the playground. I'm going to provide all the links after the talk. Okay, we have like a single file playground that you can access and create your own scenes. And you can play with the code here and change it. Okay. So that's pretty nice if you don't want to install anything in your laptop, but you want to take a look of how it works and such. So I'm here to guide you through your first 3D scene, because most of you probably have never created a 3D scene before with Vue. So we have our single file component, and then we import the main component, or the most important one for the rendering, which is the TresCanvas. So the TresCanvas is going to be the responsible of taking everything that you put inside and put it on the canvas element, or the DOM element of the canvas with the 3ds in. There's a property that you can set to put it by default, it's going to take the width and height of the container, so you can containerizer. But I don't know if that's even a word, but you can put some boundaries, so like the canvas in your website. Or you can put a window size, and it's going to take the whole thing. So the next you want to do, it's a good practice to separate the canvas one. So similar to how you do with Nuxt, that you have the app.view and you have Nuxt app, Nuxt layout, and then you have your routes. Something similar you can do here, and I tried to use a component for the experience itself. So if we go to that component of the experience, the first thing we need to add is something to view the scene. Okay, so to be able to see things, and there is two cameras that we can add: the perspective camera, which is the most similar to how our eyes work, and there is the orthographic camera that is similar to for those of you that play video games. There are some games that are isometric because the deepness is wow, it's really difficult to explain how it works, but it's isometric. It's a way of like rendering the objects. Then you can add objects into it. So the way you do is like you do with any UI component that you build. You have the Tres mesh, and I like to do the analogy between geometries and materials with CSS and HTML. So the geometry is going to be the structure of the object that you're going to render. So you can think of it of the HTML. And the material is going to be the CSS. So all the visual properties, the color, how shiny it is, if it's reflective or not, if it's metallic, all that is going to become the material. So when you pass these two as via slots to the Tres mesh, it's going to take it as children. The way you can pass arguments is via this prop argument, and they are going to become the constructors of the 3.js instances. Okay. Let's try to render this and see what happens. So if you run this code, it's going to look something like this. It's going to be like a pink sphere. And congratulations, woohoo! You actually did your first 3D scene ever. One thing that 3D has is that it looks really intimidating for starters. And one of the goals that we have in TresJS is actually make it simple for people to start using it. So let's go a step further and try to do more fancy stuff. So with this, we have another package that is TresJS postprocessing. So the TresJS core is the core package. You can do everything with it. But we add a layer of developer experience with several packages. So you have Cientos, which is the view use of TresJS. So it's like a conjunction of different abstractions and components to make your life easier. And we have post-processing, which is completely dedicated to this concept of After Effects. And here is the documentation. We're going to change it later in summer, but you have all the information of the different stuff here, all the different effects available that you can play with them. And it has some really cool, like, live. This was from the team. They created really amazing demos that you can play around with them. This one, I didn't even know that we merged this, so I'm actually testing it for the first time live here. It looks really cool. Sorry. So getting back to the slides. We have two kinds of effects. We have the 3.js effects, which are based on add-ons on 3.js library. And we have another ones coming from Poimandres. Who is Poimandres? Poimandres is the first ones that created the declarative wrapper of 3.js. They are the creators of React 3 Fiber, which is the 3D way of doing things in React. They actually were the ones helping me creating the POC for the TresJS with all the concept of the custom render. So we took their library, and we also, because it's really used in the community, we also made it available through Tres. So the way you add effects here is you have the two types. So for the TresJS effects, you can import them from the TresJS post-processing. It's going to be a component, a wrapper component called EffectComposer, and then you can import any of the effects. And the way you are going to use them is that you need to wrap them in a suspense, because some of them are asynchronous. So they have an await inside, and you need to wrap everything with a suspense in Vue. And you have the EffectComposer, and then you can pass as many components, effects that you want. And the order is going to be respected. So if you put Unreal Bloom and then the glitch one under the hood, is going to respect it. As any other component in Tres, you can pass some properties to tweak it out. So how do we enable emissions for the bloom? Okay, the bloom is the glow. We need to go to the standard material, and then aside of the color that we want to use, we need to set the property of emissive with the color that we want to glow, and the intensity that we want that material to be shiny, or like to glow. And yeah, it glows, amazing. It creates this cool effects of the penumbra here, where it looks like a star or like a sun, right? But then we can try to implement the same with the point address library. So the way you will do it with point address is going to be pretty similar, but all the point address components are going to be suffixed with point address, okay, to avoid issues with the TypeScript and such. So same concept, suspense, and then the EffectComposer and the bloom from point address. And hey, it also glows, amazing. But you probably noticed that it's a little bit different than the other one. So if we do a comparison between the point address effect and the TresJS effect, which is based on Unreal, so it's the same algorithm or the same approach that Unreal Engine use. And the point address one, I don't have any idea how they do it. But the properties are quite different from them. So it comes the question like, which one should I choose, right? It's always a tough decision, but my suggestion will be the one that looks better and it's easier to work with. And if you like as any other creative process, the end result or how it looks or the look and feel of it, or how the end up audience will take the colors and are variables that you want to take in consideration. I'm happy that we just released it like the second major. So we had 2.1.0. Sorry guys, spilled coffee on my laptop. Ouch. So we have 3 plus new effects available. We have Barrel Blur, Kuwahara. You're gonna see what it is. It's super fun. Dot screen, lens distortion, Scanline. So we have a bunch of new effects available. I want to highlight and a special thanks to Tino and Damian, who are the main maintainers of this library. Tino is part of the core team, and Damian is an official maintainer of Tres as well. They were the ones creating this amazing library. So let's play around with some of them. I always love this part of the talk. So we have this barrel effect, which basically, if I understand correctly, this is the normal render. And then you can give this effect of, I don't know, Vercel website of distorting and adding the glare of the light in the reflection, which looks kind of cool. You can offset it, so it creates this variation here. And you can, with all the effects, you can play with this. So if you have ever used Photoshop or any like image software, you're probably gonna recognize some of this, like linear burn or things like that. You can actually apply it here, subtract colors and such. It's super fun to play with. Let's see the next one, the Kuwahara. I didn't know what it was until they presented to me. So these are 2 models of like a Monstera and Watermelon. And if you enable it, it's gonna do this effect of watercolor painting. I don't know if it's visible in the recording, but you can change how much definition do you want for the watercolor, and it gives like a really cool effect, like it was painted actually. This is one of my favorites so far. What else do we have? Okay, we have the dot screen one, which is emulates the way comics were printed in the past. So you know the comics has these dots that is aesthetic. It's like dots. You can achieve this with this effect. You can change the angle and the scale of them. So you can do it like really scale like this, and you see that you can interact with the scene super fluid. So that's a cool like approach to achieve this kind of effects. Pixelation. This is super cool. If I enable it, it converts your website or your 3D scene into a PS1 game. It's really quick. And it's really performant, actually. Of course, if you go wild with the pixel side, it could get a little bit laggy. But if you go like around this value, it's actually like playing an old game, but with proper objects. It's pretty cool. A lot of video games use this technique, actually. They fake the 2D. Could you show the compiled version of the component? I wonder how big resulting bundle gets in the production app. Oh, yeah, for sure. I can share it afterwards. It's not that big. I mean, taking in consideration that when you use three.js, it's a huge library. It does have tree shaken, but there's going to be like an overhead of things in your website, in your bundle. It depends how much importance you give to that. And for example, in a website, you try to delay the rendering or the import of all those assets in the bundle so you don't affect the performance. There are techniques to do it. This one is the Scanline, so it resembles the old-fashioned like TV screens that have these lines, especially when you use a camera. So if you are creating like a all monitor effect with some things inside, you can use this one. What's next? This one here is one of my favorite showcases from the community. They created a game where this is all Vue components, okay? This is all like composable components, and they're using the post-processing thing, so you can play with it. It's available on our laboratory website, and it's pretty cool, and it's all done with TresJS and post-processing. So what's next for you? If you are interested by this talk and you learn something new, please give TresJS and post-processing a try. Have fun with it. Let me know how it goes. Show the things that you build with it, because we often publish them and retweet them. So you can share it in Discord or in our socials. And if you feel adventurous and you want to challenge, you can always contribute to the project. I don't know how much time do I have. I'm good with time.
Yeah, we still have some couple of minutes.
Okay, because I really want to give a shout out to all the contributors that give TresJS possible. Okay, so I love that every time I do a talk, there is new ones in this render. So I'm pretty happy about that. If you feel that you are not able to contribute, even with documentation, like there are several ways to contribute, but you still like the project, you can always sponsor us and GitHub sponsors. With that, I try to pay all the different maintainers and contributors that we have on the project, so it's sustainable for everyone. I think that we are doing this after our normal jobs. So after 8 hours of work, I'm working on this for pleasure. Okay, so give it a thought. If you like the project, you can always give us a copy. And yeah, thank you very much.
Thank you, Alvaro. That was amazing talk. We still have some couple of questions in the chat. I mean, some of them from Andrii. He's asking, are materials compiled to shaders? That was the first question, and the second one is about is about compiled version in a production bundle.
Yeah, I missed the first one. I was answering the other one, the compiled version. I can share with you, Andrei, afterwards, like how it will look like. But it's not that big. But always consider that you're gonna have a little bit more than a normal website. That's for sure. We are leveraging rendering 3D on a website. So there are a lot of techniques if you are worried about the bundle size, how you can approach it that it renders in delay, or you can use the scroll observer to mount the component that has the 3D asynchronously. So there are techniques that you can use. Material compiled to shaders. Yes, all materials have shaders. So you can also, there is a material called mesh shader material or something like that, that you can pass the GLSL programming, so the shader code directly for both the vertex and the fragments. We are giving, like in summer, we are going to release the version 5, which is the next major version. So you have the news here. We are going to support WebGPU, which is the new API of the browsers to compile 3D. And that one is a huge step on shaders. They have their own language, like TSL, that is new. Does it fallbacks or only works with WebGL2? It fallbacks to WebGL1, but if TresJS supports it. So we're just a wrapper. So if TresJS supports the fallback from WebGL2 to WebGL1, then we do as well. Like everything that you can do with TresJS is available here. And every time they launch a new release, you just update TresJS and Tres is gonna work.
Cool.
Matrix vibes, yeah. Cool.
Yeah, I think we have one more from Alexander there. General question about Canvas. How do you write tests against that if you want to do it?
That's an excellent question. It's terrible. The test environment for this is terrible because we try to test everything that we can. So the custom render is test. But when it comes to the canvas, normal testing approaches don't fit because there is no interface in Node that gives you what the canvas is actually rendering. So you can achieve some testing by using like screenshots and differentiation, like image processing. So how the canvas is rendered versus how it's rendered in a different. If you do a change, if it still renders the same or not. But it's not an easy task. I have done it with not Playwright, with Cypress. I did it once, but it's not as straightforward. So yeah, like it's more creative process. It's not something that you can test. I'm glad that you asked that. We are working, or the team is working. I'm just doing the reviews for a Rapier package. So we're gonna have a TresJS Rapier physics engine in near future after the V5. We already have a lot of scenes. We have colliders. We have I think ragdolls as well, sensors. We have a lot of cool stuff coming up. So stay tuned.
Nice. So I don't see any more questions, and I would say thank you again, Alvaro, for this beautiful talk. That was really interesting and visually satisfying for sure.
Thanks. And if you have any other question, feel free to reach me out in socials. I'm more than happy to answer.
Sure. Thank you again. And we have to move on to our next speaker. So our next speaker is Volcan Akyel, freelance front-end engineer based in Paris, France, mostly focused mainly on Vue and Nuxt to craft accessible, performant, and elegant web experiences since 2018. when he's not coding, he's probably watching football or out enjoying a kind of sport and outdoor activities, which is kind of rare for programmers, right?
Yeah, that's
Nowadays.
true. That's true.
Yeah. So, hey, Volkan,
We're
I'm
kind of
passing
around.
the screen to you.
Thank you so much. Thank you so much. I'm sharing my screen right now. Here it is. Let me know if you guys can see my screen.
Yep.
Yeah. So hello everyone. I'm very happy to be here. It's my first time as a presenter, so it's kind of new experience for me. I've seen also Alvaro at Amsterdam. It was very nice, really good presentation. And today we're gonna talk about something very cool, which is Vue Motion. It's not very new. It's something that happens and is a trend that happened like couple years ago. It got hyped and it just came framework agnostic. So it started with React, and now we have this beautiful library for Vue.js and Nuxt as well. So it's pretty cool to have it. And the talk today, we're gonna see, of course, Vue Motion, and we're gonna see how we can make things better and smooth as a native application. So before starting, I'm Volcan Akyel. I'm working as a freelance front-end engineer. I've been working also as a designer, working mainly with Vue.js. You can reach me on social media with like Volcan Akyel on LinkedIn as well. And yeah, let's jump into it. When I'm not working, usually I watch sport, as you said. But yeah, let's jump into it. My work focuses a lot on design and development and how we can make things together. So especially when it comes to motion and user experience in general. So let's see how we can do it. But before talking about any type of techniques or codes or whatever, we're gonna talk about why UI and UX matters. You all probably know, but the first impression of a product that we have is largely visual, especially right now with the device that we have and all the beautiful designers that work out there. The first ID we have for a product is visual. So the animation that we can have, especially on the landing page, can build trust and engagement at the first sight. So motion adds affordance and guides all the users effortlessly through the states. And the main part also of this is that it can reduce the perceived time and wait. So if you have a slow API, of course, it's never from the front end, it's always from the back end. So if you have a slow API or even a form is taking some time to get sent, the motion can make the user feels nice with it and feels that this has been done on purpose. So this is why UX and UI matters and why motion can actually help on that. So now we're gonna talk about Framer Motion and what it is, what's the hype around Framer Motion, motion in general, and what's the econ on with that library. So Framer Motion is actually a React first library. It started with React, and it's been something that I've really been jealous about, to be honest, because I've seen many great animation that was, let's say, quite difficult to reproduce in Vue. We had to add some transition. We had to make the animation with CSS. We have to play with a bunch of things. And yeah, motion with React was very nice and very elegant way to build this. And the syntax as well. Until that Motion 1 actually started to just be framework agnostic. So as now, framework Motion works for all type of framework like Vue, Angular, React. And the best part of it is that it's very, very tiny library that you can add, hybrid and very smooth performance. So you won't have bunch of bundles coming up in your project, which is very nice. And you can play with a lot of things out of the box when you install the library, such as HTML elements, SVGs, or even CSS. And you can run up some animation at 120 FPS with native browser efficiency. Up until now, Vue had some transitions, the transition component that you might know. It was very nice for conditional rendering and very useful. But when it comes to more complex animation, we had to move on to other libraries such as GZAP, which is kind of feel like it doesn't fix and comes on your project, but more as your project has to fit on GZAP. And Vue Motion, obviously, declarative is very comprehensive and very easy to integrate. So let's get started with Vue Motion. What the things I love the most with this library is that it's super easy to install. Usually I work with Nuxt environments. So it's pretty much just an npm install, and you just have to declare it on your module. Out of the box, you're going to have this motion component that you can bind to any type of HTML element, such as button, such as divs, and many other elements. And it built in with support for gesture, timelines, and variants. So it works very, very seamlessly with views, and we're going to see what we can do with it. And we're going to start with basic usages. Before we get started on all the code, the last part that I wanted to show with you guys is actually we can make this website, which is pretty much a landing page for a city that I like a lot, which is London. Having this type of images and this type of elements coming on, to have this with Vue Motions. So it's pretty much the same component, the same pages, but we just added some couple motion elements on top of it. So we can see we have much more elegant transition coming very easily, as well as the model. We can interact with element that comes, that goes, exits the screen. So it's pretty handy. And we're going to also have a look at small playground, let's say, to have some basic animation. And so I have one where I can just play with a click and animation coming up and leaving. We're going to have also a staggering list where I can see all my items and pretty much easy to animate. The other one that I love is actually the scroll onto view. It's very popular, especially on modern website when it comes to show features or when it comes to show some articles. We will have this smooth animation as long as we scroll. So it's very communicative for the user. And if you have a lot of articles, for example, or a lot of data to show to the user, obviously it makes feels better and the weight for the user, the performance side. We talked about the value we pursue to the user is on top of everything. We're gonna also see how we can animate elements that comes and leaves. So when we toggle and we just add and remove something. And the last part is going to be just the layout animation, which is very nice as well. Just having one element, adding just a layout in a list, actually help us to move our elements in the screen. So let's jump into it with the basic animation. Here now I can just have a motion just declared, like my motion component, and I've got several propses. The first one is initial. Initial is actually my elements coming up with the opacity that I just declared. I can play with different things, which is pretty cool. With 3 lines, we can just having a great transition. We can animate them as well when they come on the screen. And we can add some transition built in. For example, this one is the spring one, the one we we see when we just jump into the component. So when the component gets alive, we have the initial states getting triggered, and then the animate, and the transition is going to help us to define the animation that we're going to have. The Spring physics is actually a concept for all designers working in the web right now. It uses different types of elements, psychological elements, in the way that we perceive things coming up in the screen. And the more smoother it appears and the more quicker it leaves, makes the user even more attached to the product he's using. So the second example is going to be our button with our, let's say, clicks counter. So here I've got one animation pretty much when the clicks counting is appearing and leaving, and the hover when I just hovering my button, which is just a simple shadow effects. So when we press the button, actually we have different other type of props that's coming out. You can see that my tag is actually, I just passed the tag to the motion component, which is in this case a button, and then I just set up the initial one, which is the scale. These ones are pretty much CSS and CSS property that just read by the motion component. While we hover, and the transition again, the one we used previously for the simple one. The rest remain the same with the Vue syntax. We got the on-click with the handle click method that's just bind to the element we have. And the interesting part comes on the button, because when we add, or when we press the button, we have this click count coming up with the spring animation, and that's where the screen animation actually is pretty interesting to see. So that's it for the second one. The third one is the staggered variant. So just for a reminding, is just when we have a bunch of elements coming up, we're gonna all see them together. If I want to relaunch it, I just press the button. Same logic as that one, and all the items are gonna get stacked on top of each other with my flex layout. So now I can add just a parent element, such as the previous one I did with the button, but now I'm using some UL elements for a list. And I can have a container animation and just say it to visible until it leaves. So in this case, it's still the same transition we have, but this time we have a way to follow up all the items with the key elements. So the key elements is gonna help us to follow up the items we are showing to the user. So in this case, we have 3 items, and Motion can actually keep track of each item that is coming up. So let's jump on to the other one, which is actually my favorite, the scroll onto view. As long as I scroll, I can see my elements just coming up in the screen with the animation I just declare. So for it, I just have to declare an initial state. And there is also an interesting props here that it's pretty new for this this element. Is the in-view options. I just set it to once. So when you set it to once, you're gonna have the elements just appearing once. Obviously by default it's false. So if you just leave it at false or just not declaring it, the animation is gonna happen just once. And as long as you scroll, you won't have it in your screen. The in-view states is actually this one. So it's actually a props as well. You can see that with just the opacity, we can play with a lot of things, and we can also have different way to attach things when it appears, when it leaves, when it's scrolling on the screen. And I really like the way that Motion makes it smooth to integrate. So the in-view states, we can add some fades and the position when we scroll into the view. Let's get back to the layout animation. So the layout animation should be that one. And the layout animation is actually very interesting because with a single element, a single parameter, we can actually keep track of all the animation for a list. And the example I like to take is actually having a bunch of articles or bunch of elements, such as blog articles, that we can we have to show on the screen, and even add some logic on it. So as long as I want to reverse my array of numbers, the layout is actually taking care of the order of each element to just realign it. So in this case, I just have a grid system, pretty basic, and with the layout property that just comes built in with Motion, in my V4, I just can keep track of each item, add the layout, and just add the transition I want to give. So here again, with 1, 2, 3, 4, 5, yeah, let's say 6 line of code, we just jump onto this massive animation that would have taken maybe more if we were doing this just with pure CSS. So let's jump onto the performance. After all of this coming up onto the project, the performance is actually very impressive because at the end, it feels like we didn't add any library. The project is still very tiny and the bundle size is very low. So the loads of the application is even noticeable. So it's ideal for mobile, but also low powered devices such as low 3G or low 4G. It's very easy to handle complex animation with it. The documentation of motion.dev has been very well written, and there is a bunch of examples coming up for all the elements. Of course, we can't see through all the features that Vue Motion actually provides, but it's actually very simple. It's expressive. And we can power a lot of things with Vue Motion. So the first class support for Vue is actually coming handy. And now we are on the same page with this Hype React library, which is very nice. There is some links and documentation. Of course, guys, you can see the Vue Motion docs, which is a beautiful one. You can see all the different elements. There is a bunch of examples as well. And there is more than 1,000, more than 100 examples in the documentation. For this small project that I just prepared, I just made different animation so you can play with it. I added the GitHub slide for this and the repo. And of course, if you want to connect with me, it's the LinkedIn and my Twitter. I just leave it as well. Thank you, everyone. And let's jump to the question if you have some.
Thank you, Volkan. That was nice. That was really cool. Thank you. I think we have
Thank you so much, guys.
or maybe even few questions from the chat. So the first one I see is, what are your favorite animations to use for websites? From Alexander.
My favorite animation is actually the one I use for my portfolio. The one I use also, this is the one I like to provide, is the scroll animation. As long as we scroll, we just have a bunch of things appearing. It's very easy to integrate. And the layout one, like the last one we saw, was also very nice to have. So I'll say easily these two.
Okay, another one from Alvaro. Is DOM oriented only? I think R3F had a framer motion to the custom renderer. Wondering if could use it in animate 3D object with Tres.
Yeah, it's mainly DOM rendered. Of course, we can go deeper and playing with a bunch of things, but out of the box is simply a component. So it's on the client side, and we can mostly play with the DOM. In the documentation, it provides a lot of examples for that. But yeah, it's mainly on the DOM.
Okay, thank you. One more from Andrii. Does the lib respects prefer reduced motion setting for A11N?
Can you repeat the question? I haven't seen it, I think.
It's the last one in the chat.
Oh, yeah, let me see. Oh, yeah, is DOM oriented now? Does the leave respect prefer reduced motion setting for? Yeah, it's actually a good question. For accessibility, it's perfectly accessible. Of course, you're gonna have some checks to do when you play with the opacity, when you play with the contrast, when you play with the colors. Of course, depending on the time of your animation, but there's a bunch of metrics to measure that. With the Chrome console, or even with the Lighthouse console, you can have a lot of insight on this. Since it's mainly on the DOM, you can have all the insight on the accessibility that you gave. But obviously, when you reduce the opacity, when you change some contrast, when you change some colors as well, it can affect the accessibility. So you have to check this as well.
Cool. Thank you. I hope it's answered your question, Andrii. Pretty much explanatory. Okay. Well, I would like to say thank you again, Volkan. Very good stuff, and congrats with your debut there.
Thank you for having me. It was very nice.
And let's move on to our next speaker, Andrii Bohdanov. You probably already know Andrii from previous Vue.js Talk number 9. He was talking about fundamentals of how we write in CSS, or how to not write CSS, as far as I remember. So let me remind a little bit info about Andrii. Andrii is architect of fast web stuff in VF Corporation, browser performance nerd, functional CSS evangelist, new retro wave enjoyer, and Stamin courts when not coding. But he can explain him better than me, so I'm passing microphone to you, Andrii. Thank you.
Hi guys, hope you hear me well. Really glad to be back for these talks. Really glad to continue talking about CSS, about performance, and some best practices. So today we will continue talking about how to basically create components, and specifically how to properly write CSS. And we will take quite a bit of an unusual topic, right? So let me just share the screen. 1 second. Hope you see it well. So yeah, today we'll be talking about the building of generative layouts, right? I know if you saw my post that preceded this talk, where I tried to explain a bit the kind of a motivation behind it. I will go over it as well in my talk today, right? So this kind of a comparison between the optimal component creation and the golden era, in my opinion, of this highly optimized retro games is not a coincidence, right? So we'll try to explore a lot of the same principles that the people were using for decades to build performance UI. I don't know if you know, but for example, Mario game budget was around 40 kilobytes in total, and the rendering part with all the tiles was around 8 kilobytes. Right? So we'll try to do even better. But before starting on that, like just a small word about myself. So I'm Andrii Bohdanov. I'm principal front-end engineer at EF Corp. Been doing this stuff in the web for more than 20 years, located in Lugano, Switzerland. So if you would like to say hi or you'll be around, just let me know. We can meet. You can find me on GitHub as well as on LinkedIn. And yeah, like we only have 30 minutes, so let's really jump into this, right? So we will take like really practical approach today. Not a lot of slides, not a lot of theory. We'll just look at this really practical scenario where you have the regular website, and most of it is really predefined, right? So if you was on the previous talk, you kind of will agree with me that the optimized system is always based on the, 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 the clearly defined design system, where all of the aspects of the system is predefined, right? So if you was on the previous talk, you kind of will agree with me that the goods, the optimized system is always based on the clearly defined design system, where all of the aspects of the system is clearly identified, right? So it means that you know in advance how your CSS will be structured, you know in advance which colors you'll be used, what typography you'll have, and all of these other aspects of the website creation, right? But sometimes there are cases where this is practically impossible, right? Sometimes we have tasks where we can't know in advance how our structure will look at the end, right? It's similar like in the game, right? So if you take Mario, the system by itself kind of just defines the rules. You have a character that can be moved, but you never know where it will appear in the next moment. It all depends on the actual user. In our case, the author or the person who would want to add content to the website, right? So talking about the point of business requirements, let's say that we have the e-commerce website, and it's pretty predefined. It's have PLP, PDP page, some additional pages that are statically defined, but at the same time, we have some marketing pages that practically depends on the event, right? Sometimes we have campaigns dedicated to Christmas, to Black Friday, to all sorts of different stuff that requires this kind of unconventional approaches in terms of using different colors, different components in the different types of layouts. And you want to kind of work fast. You don't want to kind of even redeploy your system every time this event happens. But at the same time, it's quite rare, right? Some of those events happens only once a year. So you don't want to kind of pollute your main design system with those kind of one-offs. Because we also had, on the previous talk, we had this question from attender. What should we do if our UX team is not really well organized? What if we have this kind of one-offs here and there? Like how we can actually work in this situation where we want to break through, so deviate a bit from a design system, but still keep our overall application bundle really performant, right? So again, returning back to the business requirements of the task we will be working on today, is that we have a CMS, we have specific data that should drive our page layout. So our authors in CMS really wants to form components in a undeterministic order, right? So imagine that you have components such as cards, and you want to display them as 3 in a row. You want to kind of display them one under another. It's you basically don't know the layout in advance. Your application doesn't know. You can't just limit it to kind of 3 or 4 options. You need to support way more than that, right? Because it's all defined somewhere else. In our case, in the CMS, right? Let's imagine that. And what is even more important is that this should actually be connected to our responsive breakpoints, right? So imagine that your website has a set of breakpoints such as SM, MD, LG. The design changes according to those, and those layouts should also adhere to these layouts, right? And they should be able to change based on the breakpoint size, right? So this is kind of a really high level and really simple requirements, right? Nothing really special. It usually comes from the brand or like a website author or website owner, right? And apart from that, there are always the technical requirements that we should also remember, because in order to kind of even understand why we will be doing things in this specific way today and not in any other way, is because we want to respect some really fundamental rules to component creation. And those rules will really allow you to stand out from all the rest, right? So they will allow you to get like a ultimate rendering performance and ultimate bundle size, right? So there's like certain rules that you actually want to follow in order to kind of really be on a really good side of your component structure. So first thing is that your components should probably don't have like external dependencies. Sometimes it's really hard to keep, right? So sometimes we still have dependency on external libraries. Today we had like a really great talks about the libraries that can extend functionality of your project and that you probably don't want to write yourself. But at the same time, you need to really have like this core behavior of your application written by you, so you can have full control over it. And as less dependencies you will have on external stuff, the better, right? So don't take this as a kind of really harsh rule that it's not binary, right? Sometimes you can have like a couple of dependencies, but at the same time, don't overuse it. And ideally, you should have 0. Same for internal dependencies, right? So your component should work correctly by itself. It should be self-contained. If you move it to somewhere else, it shouldn't break. If like you don't move some other dependencies that it relies on, right? So the less dependencies that have from internal stuff, the better as well. Ideally, you shouldn't have any internal CSS, right? And we also covered this on a previous topic where we seen how UnoCSS allows us to just write classes that reference global CSS that loads in advance. And in this sense, the component itself doesn't introduce any additional content for mutating the CSS object model, right? It's really crucial for performance. And the same about the client-side JavaScript, right? So if you think about it, the client-side JavaScript is only loaded when hydration is happened, right? And right now, like all these things are applicable to SSR-based application or the SSG-based application, right? Where we have the hydration phase, and client-side JavaScript executes only when the hydration is complete. For example, if you're working on the Nuxt project, it takes time, right? Usually, if you're working on really big code bases, the distance between the actual loading of the static HTML and its hydration can take seconds, sometimes tens of seconds, right? So the more reliance you have on the client-side JavaScript to build, especially layouts, the more you'll get this jumpy behavior, right? Because your final building of the layout can't happen before hydration is complete, right? And for example, like one of the approaches we could have taken, and sometimes people are taking to like layout scenes on the screen, is to rely on client-side JavaScript. So for example, you probably used Vue before. There is this library that allows you to detect the screen size of the user, but only client-side, right? There is, unfortunately, today, no reliable way to propagate the size of the screen from the server side, where you don't have the browser environment or the user data yet, to the client. And that means that you'll inevitably have the discrepancies between the server side and the client side, right? So we wouldn't be using this today. We will rely on a bit different technique that doesn't require any client-side JavaScript. And I'll show you this, right? So after we'll complete what we will be building, I will disable JavaScript in the browser completely, and it should still work, right? This is like a really good criteria of a bulletproof component. It only relies on the HTML and CSS, and the JavaScript is only used to generate those, right? So it's not used on the calculating anything in the browser environment, so to say, right? Also, SSR-first, right? So it actually should be compatible with SSR. It shouldn't kind of require client-side only. Any additional components from Nuxt, it should just work in both CSR and SSR, right? It should be really lightweight. And the better you will do, the smaller components will be, the faster it will be, right? And sometimes people don't realize it deeply, especially if they're not working yet on the really big systems. But this whole effect of accumulation of components and additional dependencies really grow your application for the user, right? If you're talking even about like adding 3D or adding additional heavy libraries to the website, you should always analyze the performance aspect of it, right? Because it's not the only library that will be loaded usually. Usually, you can have like up to like 400, 500 requests just to initially load one page. That's kind of a really harsh reality of big projects. You need to load a huge amount of JavaScript. And we need to, at least from our side, make this value as small as possible, right? So today, we will try to keep our budget really low. We will try to create our whole component under 1 kilobyte gzip, right? and it may be even smaller than that. It should also allow to, as I said, change the breakpoints, right? So if I'm changing the screen size, it should just work, right? It should work without JavaScript enabled in the browser, right? All based on the CSS. It should support the deep caching. It's also a really important point because most systems in production use deep caching. No matter if you use Netlify or Akamai or any other system for actually pre-rendering your web page, you will actually get into this situation. Even if you have this mechanism of detecting the type of device and the screen resolution of the single user, if you're using deep caching, that will never be available to you. It means that you will get this information only from a really first user that hits the page. After that, all the subsequent calls to the page should return the cache. And that means that SSR will always be cached, right? Nuxt won't be hit after the first access of the page. It will, your SSR, and that means that your SSR should be fully deterministic. It shouldn't make choices based on the actual user that came to you, because like basically you have cache. You can't control that, right? So we will make sure that our component actually deterministic for all users, but it works perfectly for all screen sizes without any lag or CLS. And also another really important point is minimal hydration or no hydration ideally, right? So if you've been following Nuxt and Vue recently, we got like a native support for deferred hydration or lazy hydration, as it's sometimes called. And that means that now you can control when your component is actually hydrated, and you can disable the hydration completely. So what we will do today is after building the component, we will completely disable the hydration of it, which will actually simulate the same effect of disabling JavaScript in the browser for the user, right? We will kind of make sure that we only work with static HTML and CSS, but we won't execute any JavaScript after the initial render. Right, so again, of course, this is not an exhaustive list of all of the principles you need to follow, but this is just like one of the most important one, in my opinion, for high performance. Right, so let's get started. Let's get into the code. So if you want to follow along, just clone this repo. We were using it last time. Now you just need to check out the API start branch, right? And you'll see exactly the same start that you'll see on my screen, right? So you need to install dependencies, and let's keep rolling, right? So let me just open it, right? So this is the project. Let me just maybe zoom it in a bit, so you would see it more clearly. Is it better like this? Let me check the chat, by the way.
Yeah, it looks okay.
Okay, great. So yeah, let's start from like overview of what we will be building, right? So I'll try to kind of get through it quite fast, but I'll get you like the idea of all the parts that will be in motion here, right? So first, let's start from our Uno scene, right? So for this specific demo, I will be using the preset that is called Mini, right? So I really recommend you trying this preset. Let me just check the main Uno config file, right? So as you can see, I'm using the preset Mini. This is the most minimal preset that doesn't generate any extra CSS that you might need. For example, it doesn't generate container by default, right? So it's like the most minimalistic starting point that you can use, and it's really a great fit for minimal projects, as the one we have today, right? So we will start from it. Then we will have our fun preset, and it's a bit different than the one that we used in our first session. So let me quickly go through it. So first of all, we have really easy pre-flight that just resets our margin. We set it to 0, right? So nothing special. Then we have the actual presets followed in the fonts, just the regular stuff, right? To display, nothing fancy. We have one shortcuts setting that we will look into a bit later, and we have a theme, right? So in the theme, we connecting our breakpoints. This is a really important point that I always start from when developing the basically any project based on the design system. I'm trying to kind of keep my design system clearly defined. All the custom stuff that I write, such as breakpoints, should be described separately and usually in JSON format, right? So I really like using JSON for this because it can be imported into basically any environment, whether it's a Vue, Node, or Uno. It can be consumed by anything, right? So it's a simple set of settings that I use globally, right? So this is the only breakpoints that our application will support, and there's a general recommendation to keep it to a minimal, right? So we just define the breakpoints here, and we are loading them in our theme here, right? So I'm using like a really tiny helper here of mapping the object. It just allows me to traverse the object in a similar way as if it was be an array. So it's kind of the array.map function on the object, and I'm just adding the pixels to it, right? So this is the requirement for proper work of Uno breakpoints for their recognition. I'm just adding the pixels in here and getting the final object inside of the breakpoints, right? So this is how you can connect your media breakpoints to a theme in a really minimal way. Let's move on, right? So one of the key concepts that you should already understand in order to get how we will build this component is understanding of the CSS grid areas, right? So if I go here, and again, like grid as a standard in CSS is huge, right? It has so many rules, so many different aspects. It's really advanced. One of the aspects that we will be using today is called grid area, right? It will help us define the area of our section, so to say, or our component. And again, like even this property can be specified differently. And today we'll be using this type of syntax. So briefly, what does it mean is that it allows us to define where the component starts and where it ends on the grid, right? So this is just 4 values. It's kind of a combination of span and the starting position. Let me check the chart. Yes, so the question is when do I use grid versus flex? I try to prefer flex whenever possible, just because it's a bit easier subsystem in CSS, right? But for this specific case, flex just won't cut it, right? It's like the task is too complex for flex to gracefully pull it off. And and I will show why, right, in a second, like why we even use CSS grid here. In order to understand like how we will be forming our component data, we need to check this project. I really recommend you checking this open source project by Sarah, right? So it's a CSS grid generator. It actually allows to generate the structure or the grid not by 9,999 options, but basically to infinity, right? So you can have you can actually define the like the grid of 1 to 1 to 1 trillion to 1 trillion cells if you want, right? So it's literally endless, and it doesn't grow. The component itself, the logic of it won't grow. Only the response of your data might grow, right? If you kind of increase the complexity of your layout. So really interesting project. It's a fully open source. You can check the like the actual project. Let me just go to the GitHub just to show you, like, you can clone it yourself. And again, today we don't have time to kind of create a full-fledged CMS layout for this, right? But you can actually use it inside of, for example, Contentful. You can just install it as a module, and you can use this layout visual editor for your authors to visually lay out the component on the screen and then just receive the data from it, right? So you can modify it however you want. So it's It's fully like, I guess it's under Meet license. Really cool stuff. So today we will just use it to get the general idea of the contract that we will be following, right? And get this kind of a visual representation. So let's say we want to build our components in this form, right? So imagine that you have some components that you want to position on the grid in a specific way. You just do it like this, click, show me the code. As you can see, you got two sections. You got the actual layout of a parent, and you got the divs, right? So each div has this grid area, and it defines where it starts and where it ends. So this is all the information that we will need here, right? So following this same idea, we will just create our JSON with our data or our API endpoint using the Nitro H3 server, right? So if I go here, I already have this section 1 JSON file. As you can see, I'm placing it inside a server assets folder. That's where the Nuxt expects this type of file. It works quite similar to client-side assets that you place inside of the root, but only for the server, right? And this in API, we have the endpoint. As you can see, we have CMS section, ID. If you used Nitro before, it will be quite familiar to you. If you didn't, I highly recommend checking it because it allows you to really easily serve JSON files and even do like tons of complex stuff in Nuxt without any additional dependencies. So here, as you can see, I just have this get item, which basically returns me the version of the JSON file from the cache based on the ID that I get from the router param. Similar concept that you used in Nuxt pages, right? So here I will just load this file, and now let's populate it with data. So let me just quickly copy some stuff, just not write it by hand, right? So you can see I created this layout and items, right? So pretty similar to what we've seen before inside of the grid editor. I'm just defining the grid, but a really important point, I'm doing it per breakpoint, right? So my interface of both calls and rows, as well as the items areas, are defined with SM and DLG breakpoints, right? So let's see how it all looks. You can just go to our, like here I have the two components. One is the section, and in here we just have like a predefined section. Let's actually build it up a bit, right? So I will just make a request and display it just to see that I'm getting the data, right? So I'll have this section. I will take pre, check the layout and items, sorry. Just to see that I'm getting the data. So let's run it. Oh, nice. What's this? Nuxt is not recognized. Yeah, I forgot to install dependencies, you see? So let me quickly install the dependencies. Feel free to ask questions even audially if you have any while it's installing. Right, so dependency installed. Let's run it one more time. Let's go to the 40,000. So let me just see if I'm running the right one. Let me check. Yeah, so like a small question about the props for this component. Let me just explain it briefly, right? So here you just have an ID. I'm passing it to the section. But it seems like I have some kind of vacation going on. Because it's showing too much of what has to be seen. Let me just try to, maybe I'll just have it in the second one. One sec. No, it's strange. It's actually quite strange that I actually already see the final result, although the component itself is not yet built. Let me double check. Let me restart and check that it's not running. Yeah.
I see that the path of your project is font CSS, while the project is font CSS too.
Yeah, nice catch. Let's run it like this. Yeah. Let's install dependencies again. I guess it will be quicker. That's what happens when you actually want to make scenes go step by step. Let's do it again. And now we'll see, as you can see, like all of the ESLint rules are picked up because we have the dependencies, right? So this is already fine. And we can see we got the data, right? So this endpoint picked up well, right? So we are receiving the data. Now let's build the component itself. And here is where the interesting part starts, right? So in order to understand our next core concept for building this component, we need to go to UnoCSS playground, right, and explore one interesting concept that actually quite unique to UnoCSS, right? So it's something that you can also achieve in Tailwind, but not so in such a nice way, so to say, right? I'm talking about the generation of CSS variables. So in order to kind of generate the CSS variable for a property in UnoCSS, it's quite easy, right? So the only thing that you need to do is write the actual property that you want to specify, such as C. It can be text, right? So any property supports this. So apart from like having this like text to Excel, that will generate you like predefined value from a design system, you can actually generate the kind of the CSS like CSS variable driven property, right? So if I specify just text minus text, you'll see that I got this selector that generates the color that references the CSS variable, right? And this can be anything. It's just my personal preference to kind of match the actual property name. So if I'm using C, I will specify C here as well, just for the consistency, because it's really important that you need to understand that you can reuse these properties across all of your components. Because of how functional CSS is done, you won't have any conflicts of using the same names for CSS variables, because this variable will only have a scope of this div, right? So even if I'll have two divs here, right? So if I have two divs with the kind of like, let's have some text in here, right? So let's try to kind of style this block of text in different color. So if I specify the line style now with C equals to something like this, as you can see, the color got applied. And if I specify similar property but with a different value here, like, I don't know, like this, as you can see, I got different colors. So there's no clashing of using the same variable. And that means that you're already kind of saving a tons of CSS by doing it in this way. But why do we even need to do this in such a way, right? So why do we even need to generate CSS variables? It's all boils down to media breakpoints, really, right? Because if you want your layout to only be defined once without any respect to the media breakpoints, you can actually use just inline style, right? So you can just dynamically insert actual property, CSS property dynamically here from your server, from your response. It will just work, right? So you don't even need UnoCSS for this. But where Uno shines is where we need to do something like this, right? So you want to say on MD, I want to have CMD, right? And now I kind of allows to specify a different value here. I generated the media breakpoint, right? And now it references this variable. And now I can define it as well. I can just specify CMD. And here I can define different color. And you can see now it changes per breakpoint. If I resize the screen, now my color is changing per breakpoint. And this is essential to understand, right? So as you can see here, we're not using any JavaScript to define this change per media breakpoint. We're not looking specifically on the screen size of the user. We're all generating this statically in many ways, right? So we're not dynamically injecting anything. We're just specifying everything in advance, right? And the same can be specified for LG. So I'll use exactly the same pattern, CLG, right? And those values already automatically connected to my design system breakpoints. As you can see here, we got those default ones, but in my case, it will be different because I specified them in the config previously. So I will specify here CLG. So there is two minuses, right? So I got a new keyboard, right? Something like this. And now, as you can see, if I resize, I got all those colors changing. Maybe let's pick up a bit different color for the LG. Let's check our syntax. Yeah, so it all works, right? So we defined our color statically through all three states. And this is basically the essence of how you can use pretty much any CSS property to be defined statically. And this approach allows you to always serve from cache, right? So the browser will decide what to use. You don't need to kind of manually detect screen sizes, or you use any libraries. And as I said, like you can write all of this by hand, but UnoCSS just simplifies all of this significantly, right? So this will be like the base of our approach, right? So let's just connect this knowledge to this contract that we have now. So let me just show you like the final version of our component, right? So as you can see now, I use the same exact approach to connect those properties to grid columns. So Uno allows us to generate the calls and rows, which actually boils down to this grid template rows and grid template columns. As you can see, I also reference the CSS variable here. And I'm connecting my layout to those SM, MD, LG properties. And if my layout won't specify any of those, it won't be even added to the component, right? So, and again, some people usually call them HTML purists. They're really concerned with the size of generated HTML. But for them, I prepared like a really specific performance test that I hope I will have time to share, right? But yeah, that's basically it, right? So we just connect our layout data to those CSS variables, and we also specifying the style, as you can see here, right? Here we are iterating over components that we have defined in the like in this folder, right? So in order for them to properly load, you can see I have this component using is lazy CMS type, which basically boils down to module, and I can have like multiple of those components. Let me just add some, right? So I'll just copy some components that I can switch between, and I will look into the structure. So here I actually use the same exact technique inside to define the BG color, again from my response, but the only difference is that here I'm passing the color as a prop, instead of like making the request, because the request was made already before. And I have this type of the responsive, and the responsive is just the interface of SM, MD, LG properties, right? So this is the kind of generic that is string by default, which will work in most cases. So let's again look at the section 1 JSON. As you can see here, we got these items, we got these areas, we also got payload. Payload is the data that you pass to the component. In our case, it's color. As you can see, I defined the color for SM, MD, LG, and also I'm saying which component I want to load. So by just this small interface or this small API response, I'm able to switch between those components and render a specific component in a specific section, or rather give my author a possibility to select different components that can be available in CMS. In a sense that I want this specific area, I want to place specific components inside of it, and that's how I want to combine those, right? Let's see how it all will render now, right? So let's switch back to our page. And as you can see, I got these components stacked pretty much similarly to how I had it in here, right? But the only difference now is that it works for breakpoint, right? So now I can have a layout that displays completely differently for breakpoint, and this is using zero client-side JavaScript. I only use JavaScript as a generator. Basically, I use Nuxt as a PHP framework. I'm just generating HTML and CSS, right? So you can see all of those properties assigned, right? And how they are assigned. Pretty much it's not that big, even in terms of like the pollution of HTML. It's still minimal. And again, like it's not that you need to write every single property like this to achieve this result. It's more for these kind of edge cases where you don't know the kind of the layout or the final value of your CSS. You don't want to store it on the client. You want it to be like fully API driven, right? So let's prove the point that I made initially. Let's just disable JavaScript in the browser and update the page. So you can see now there is no JavaScript whatsoever. It's fully disabled, and it still works, right? If you notice, there was like a zero layout shift, right? Because those components, they are fully rendered with inline CSS, which is like really, really fast. There is no point where the CSS is getting injected after the initial paint, because we don't have any internal CSS in the component that will be injected. It's all referencing globally available values. And we also don't grow in number of CSS variables for each component or each property. It's just like always limited to one property that we are using. So for example, if you're using grid rows, it's limited to grid rows, right? So you might notice that here I'm using a bit unconventional syntax for grid areas, because in UnoCSS you will see that it actually will be a bit different, right? So in order to generate the same property, I would need to specify grid area, like so, right? So if I just specify GA, it won't work, right? It won't generate anything, but that's something that you can do, right? So since UnoCSS is so flexible and extensible, if I want to kind of save a bit on my size of my utilities, right? If I want to kind of make it smaller, I can just use a shortcut, right? So if I go to the shortcuts of my project, you'll see it, right? So let's go to our preset. That's like shortcuts. As you can see, this is my shortcut. So I just mapped the grid area to a smaller GA with just this one line. And that will allow me to use this smaller syntax and make my CSS and my HTML classes even smaller, right? And that's how it works. That's why this GA generates this grid area, right? All those classes, which is pretty neat, right? So let's re-enable JavaScript. Right, as you can see, it's also not making any additional renders, but we can make it even better, right? So how we can disable the hydration of the component completely if we want. right? So if I go to my page, let me open pages. As you can see right now, I got this component, which is kind of a normal one, but I can actually specify here when it should be hydrated, right? And this is will work only in latest Vue Nuxt, because it's something that was added recently. I can just specify that it should be hydrated never, right? And that means that this component will never be executed on the client. So if I, for example, add onMounted here, right, and just put some console log of mounted, let's first remove this just to prove that it's actually outputting something. Let's go to the console. As you can see, it's been mounted, right? But now let's add this hydrate never. As you can see, no hydration is happening, right? So any hook that is relying on client-side execution won't execute. And that means that the component is fully static, even though it's not the same as this kind of island architecture, where you have this kind of server-side islands, where you don't have even like JavaScript in the client bundle. Here we still have JavaScript in the client bundle, but enabling JavaScript in the browser for the user. And it's something that we now can use because we're not relying on client-side JavaScript whatsoever, right? So this can additionally optimize our performance further. You can use like hydration on interaction. You can use all the other types of hydration. If you want to check this specific behavior, I really highly suggest you checking the docs of Vue and the docs of Nuxt, right? That's something that allows you to further improve performance of your components. And we can actually use it because of how we design the component. Let me quickly check the chat.
Well, I just dropped the message that using all of these benefits of creating variables is even better when using another feature of UnoCSS, which is grouping.
What do you mean?
I mean, we can group different things under the breakpoint or any other modifier.
Of course. Here we're looking only on the specific behavior of CSS variables, right, and how we can actually use it effectively. But of course, you can combine it with any CSS features, like UnoCSS features. But let's actually go a bit further, right? So I want to really prove you how, what is the size of this component that we just created, right? You might guess that it's actually quite small, right, because of like the generative nature of it, right? So you just it's not like right now you're looking at 3 sections. And again, like just because I'm moving really fast, I can't show you like all of the use cases. But imagine if you want to grid of you want to position the components on each other. Imagine that you have like a background image component, you have a button component, and you have some kind of a video component, and you want to make a hero banner. You actually can, right? So the CSS grid form standard doesn't forbid you to place modules on top of each other, right? So for example, if you want to even take it further and do something like, let's maybe do it like this, and let's maybe draw it like this to be our background. There will be a button here, there will be a video here, there will be some text in here, and something like here, right? So you can actually put literally thousands or like tens of thousands of components if you like so desire, right? To build or arrange really complex structures. And I also want to show you like how it connects to performance and the bundle size, right? So what we will do right now, first, we will generate the bundle size, like the bundle reports with bundle analyzer. I don't know if you used it previously in Nuxt, but you can use it through Nuxt here. Let me show you like how I set it up. So I have this PNPM analyze, which basically execute Nuxt analyze, and it will build our built with the analyzer inside. Right, so let's do it. And let's check our bundle structure to understand the size of our components. So now you can see we got this nice scene that you can access outside of the network if it's exposed, right? So, but we'll just go to the actual output folder, public, Nuxt. Maybe let's go to just public, and we will open it in our in our Explorer. I wonder if it's not even. So let me check. Yeah, let's go like this. So now our localhost 3000 should display our experimental bundle stats, right? So go to the client, and here our analyzer, right? Let's close this for a moment, and let's search for section. So let's check section, and also we'll see gzip size, right? Sometimes it's just not as good as I want it to be, so you can just use regular search to be a bit easier, right? So here you can see that we got this section component. It's actually 404 bytes, so it's half a kilobyte broadly and a bit bigger gzip, right? So even like rendered, it's unwrapped out of the archive in 1 kilobyte. So basically, like we already have plenty of room for kind of adding some stuff in. So let's check what is the size of our CSS that's been generated. For this, let's run the project again, and I like to check it through Nuxt DevTools. Right. Sometimes my laptop is lagging a bit. It's too hot in here. Right, so we'll just run the project again, and we'll open Nuxt DevTools to actually check the size of our generated CSS to see, like, like what is the actual size of it, in a sense that. And again, like this is the final size. This won't grow even if you have 1 trillion, right? 1 trillion cells and 1 trillion components. This is just a description of the mechanism. This is this cartridge type size of your game, right? You can actually write it to the cartridge really easily, and even several of those, right? And it will work. It won't require any additional updates, any additional releases of your system to production. You just kind of sell the cartridge to the outside, and it will work for like 10, 15 years, or even 100 years. Because like this is just the description, generative description of the mechanism of your system, right? It doesn't require any change when you add the components later, or add the complex structures later. Let me update the page. Sorry. All right, so now let's go to the Nuxt DevTools. Let's go to the UnoCSS. Let's check. As you can see, our whole CSS, and again, it includes everything with fonts. It's not just like the kind of the file that we got, but our whole CSS for the project is 1 kilobyte and 27 bytes, or 270 bytes, right? So it's also really, really minimal. As you can see, this is everything that got generated. I also got these kind of additional classes that I used here and there for like spacing, but the key of it is basically inside of here, right? So this is the stuff that we've been using. As you can see, it picked up my custom breakpoints that I specified, right? So this is how you can build this type of component. And again, like you can in the production system, I've been building stuff that relies on hundreds of CMS components, and the bundle size is usually like when you follow these principles of development, the bundle size is never more than like 60 or 70 kilobytes for the whole system, right? It supports like thousands of different permutations, different ways of expressing it. But I actually have one really kind of a bonus point about the actual syntax, because I understand that you might think that this is a bit more verbose, right? So you need to write a lot of repetitive code, and if you probably most of you saw already, like this can be improved even further, right? So today I don't have enough time to kind of dive really deep into future optimization, but I just want to show you like how it can look in actual production code, right? Because here I just wanted to be really verbose about how it looks and how it works. But let me switch to this different branch that I have. Let me just remove all these changes for now. One sec. Just so I can switch, right? And I want to show you like how this can actually look in an optimized way. So this is everything the same, but here I'm using a specific directive that I built myself to just generate same stuff, right? So I'm combining the power of Vue directives with UnoCSS. That's probably like a really nice separate topic to discuss in the future. But as you can see, it just allows me to pass the same data from the server into this V-style directive, and I can generate exactly the same responses, and it will work exactly the same. I can specify separate properties that I want to connect to, and as you can see, I don't even need a component. So I'm really a big fan of like functional approach, both in JavaScript and CSS. So sometimes you don't even need to create a separate component to describe some mechanism. Sometimes directive will do even better, right? So here, if I go to my module, you see I also use V-style here. So I got this BG, and I connected to color, and it magically generates me both the classes and the inline styles with variables, right? If I run it, just to prove you that it also works. As you can see, I got exactly the same result, right? It's all exactly the same. It still generates me these kind of same structures, right? But I don't need to write them by hand. And now coming to our ultimate question for people who say like, oh, but how it actually affects the performance of rendering? Like your HTML should be really clean. So let's find out, right? So let's first measure the performance of rendering of this page through performance tab, right? So let me just run the quick performance. And again, like you can use this. Let's maybe restart, right? It's already rendered, right? So let's check. As you can see, my LCP, largest component paint, is below 1 second, and CLS is 0. And this is like really important. Using this technique will always give you CLS of 0 because of the things that we discussed, right? Because you have everything preloaded in advance. You're not injecting any additional CSS. But let's look actually of bottom up what's taking this precious milliseconds. So if you look at the parsing of HTML, it takes only 71 milliseconds, right? And the self for it is 10 milliseconds. If I unwrap this, you'll see that it actually executes some additional functions, which is JavaScript, right? If I'll disable JavaScript, it will be even faster, right? So the self command is like 10 milliseconds. But let's actually run the main test, the much harder test. Let's switch our data object to contain a bit more components, right? So if I go to the server assets, I have this section 2. If I collapse it, and let's give it a bit of time because it's quite huge. It contains 1,000 components with pretty much the same layout, right? So now I have not 3 but 1,000 components that will be rendered on the screen, right? Let's switch to it. So for that, I will just update the ID of my component to 2 to load this additional JSON. It should like lazy load it. right? So it should support HMR. So let's update. Let's check the DOM for the update. And you can see now we have a bit more components to render. Right, 1,000 to be precise. Of course, you don't see them because they kind of just nested on top of each other, but nevertheless, right? So here I want to show you the exactly aspect of effect for the parsing of the HTML structure, because now we're serving everything in one go, right? Let's run the test again for the performance. As you can see, it was quite fast. And the LCP, again, CLS is 0. This LCP changed insignificantly. If I check the parsing of HTML, it increased by 2 milliseconds, right? So here we are talking about the increase of the parsing, like of the time spent by less than 10% for the 1,000 of elements. So that actually means that the parsing of the HTML is the most effective and the most optimized mechanism that exists in the browser. Your JavaScript will always dominate the budget of your performance. It's always eaten much faster. Look, no matter like how you will do it differently, it will be slower, right? If you want to kind of express your complexity in some language, do it always in HTML, right? Because HTML is the most fastest thing. It existed from the first day of browser release, of every first browser. It actually parsed and executed really, really fast. Faster than anything else. Faster than CSS, faster than JavaScript, and so on, right? So this is like, that's where I want to wrap up. Sorry again for running a bit more than I probably should, but I really wanted to show you like this whole picture. Feel free to ask any questions.
Yeah, thanks, Andrii. I wonder if there are any things that you haven't tried to improve in the matter of performance.
Yeah, I'm really a nerd about it.
Yeah, that would be also cool. Not today, but that would be also cool to have a comparison of rendering this stuff using GS. I mean, common approaches using GS, some composables that detect in the resolution of client screen and stuff like that. Maybe we will make it just as a bonus for some another talk.
Yeah, but like it definitely will be slower, right? Because as I said, if you combine it or put it on top of the everything else that needs to be executed in JavaScript, your layout will need to wait until it will be properly formed. And you always will have these jumpy layouts that first will render in one way, because you need to kind of first render the HTML with at least some styles, right? And then you need to recalculate them with JavaScript. It will be magnitude slower, right? So even like we can spend time on comparing this, but I can guarantee you that I've been through this, and I can assure you that it will be like magnitude more slower.
Oh yeah, I personally trust you, but you know, if someone wanna try, why not?
Yeah. I encourage people to like test it in like real scenarios, right? You can always take this project as a base and play around with it and try it for yourself.
Yeah. Thanks again, Andrii. I think your talk was really beneficial for people who have the similar setup on their projects, like CMS-driven or API-driven styling of the project. This is really a great example of that. And yeah, I'm reminding you guys that we have a YouTube channel, and this video will be posted on this channel. If you also want to participate, I'm dropping the link in the chat, and you can fill the form, and we'll see. Maybe you will be our next speaker.